Hi everyone, this is Mr. Cervone. Welcome to my math channel. In today's lesson, I would like to go over homework 8.3 on proportional perimeters and areas in triangles, specifically numbers 3 and 5, due to the high difficulty level. So here we're given the following. Points P, Q, R, S, T, and U are on the sides of a triangle ABC as shown, such that line segments UR, QT, and SP all pass through point X and are parallel to segment BC, CA, and AB respectively. Prove that PQ over BC plus RS over CA plus TU over AB is equal to 1. So how do we solve this problem? So in order to solve this problem, we have to somehow recognize the areas of these triangles and somehow relate them either to the bases or to the scale factor squared. So for example, here we know that segment PS and BA are parallel. So what can we conclude from that? Well, we can say that angle XPQ and angle ABC must be congruent, because if two parallel lines are cut by transversal, then corresponding angles are congruent. Then we know that segment TQ is parallel to segment AC, and similarly, we also know that angles PXQ congruent to angle BTQ and is congruent to angle BAC as shown in the figure. But again, we have those because of the parallel lines. Well, we can conclude that triangle ABC has to be similar to triangle XPQ as shown in the figure because of the AA similarity postulate. So basically, those highlighted triangles are similar. Now, since they're similar, we know that the ratio of the areas of these two triangles must be equal to the scale factor squared. So basically, we can say that the area of triangle ABC over the area of triangle XPQ, that is equal to segment BC over segment PQ squared, which is equal to BC squared over PQ squared. Okay, so how do we proceed now? Well, the next thing we want to do is draw segment BX and CX, as shown in the figure. Now we can compare triangle XBC with triangle XPQ. If we look at triangle XBC, and let's say we drop the altitude and call it H, as shown here, we know that the area of triangle XBC is simply 1/2 times BC, which is its base, times the height. Similarly, we can now find the area of triangle XPQ. So the area of triangle XPQ is 1/2 times PQ, which is the base, times the height. Notice that both areas of these triangles, XBC and XPQ respectively, share the same height, H. So let's divide both of the areas of these triangles. So if we divide this out, what do we notice here? Well, we notice that a few of the items will cancel out here. For instance, 1/2 will cancel and the height will cancel as well. So we're actually left with BC over PQ. Okay, so now we know that the area of triangle XBC over the area of triangle XPQ is simply the ratio between the length of segment BC over the length of segment PQ. Okay, so what should be our next step? Well, what we can do here is simply divide both of these equations. So basically, we want to divide the bottom equation of XBC over XPQ by the equation on the top, which is area of ABC over the area of XPQ. And what do we obtain here? So we obtain the following. And again, if we simplify this, we end up with PQ over BC. Notice that there's something else we can do here now. We can actually cancel out the area of triangle XPQ on the top and on the bottom, basically the numerator and denominator, and it simplifies to the following equation. That the area of triangle XBC over the area of triangle ABC is simply the ratio of the segments of PQ over BC. Let's analyze this now, and maybe we can see a pattern here. So let's highlight the triangle XBC in yellow And let's highlight triangle ABC in light green as shown here, okay? So what do we notice here? So we have triangle XBC and then triangle ABC. So for triangle XBC, we're using the length from P to Q, okay? And then for triangle ABC, we're using the entire length from B to C. So maybe we can use the same logic for another triangle here, okay? Okay, so in a similar manner, let's look at another set of triangles here. For example, let's compare triangle AXC with ABC. So here are the lines drawn. If we follow the same logic for which we arrive to the fact that the area of triangle XBC over the area of triangle ABC is equal to PQ over BC, how can we apply this to triangle AXC and ABC? Well, in this case, we can say that the area of triangle AXC over the area of triangle ABC is simply RS over CA. Again, we can highlight the pieces as shown here. Now we can switch focus on the other set of triangles. Now let's look at triangle AXB and triangle ACB or ABC. And again, we can arrive to the same conclusion here, that the area of triangle ABX over the area of triangle ABC is simply TU over AB. And again, these are the highlighted pieces. Okay, so now that we have these three equations, how do we use this information? Well, let's just add them all up. Okay, so here we add them all up, okay? And notice that on the right side of the equation, the common denominator is the area of ABC. Okay, so if we rewrite it as one fraction, all we need to do now is add up the areas, okay? So if we look at, for example, in the numerator, the area of XBC, okay, so that's the one highlighted in yellow here. Then we add up the area of AXC, which is the area highlighted in green here. And then we'll add the area of ABX highlighted in blue. So if we add up all these areas, we end up with the area of triangle ABC. And notice that now we have the area of ABC in the numerator, but also in the denominator. And if you divide both areas with equal quantities, the result is simply 1. Okay, so this means that we have proven the fact that PQ over BC plus RS over CA plus TU over AB is simply equal to 1. Let's now look at problem number 5. So here is number 5. Let's say, according to the diagram, we're given that triangle DEF with exterior angle FEG, and we're also given that ray EH bisects angle FEG. How do we prove that DH over FH equals to DE over FE? The hint here is to draw ray FJ through F parallel to segment HE. Well, the reason why the hint is there is so we can use similar triangles and then set up a proportion. So which two triangles can we prove similar in this case? Well, we know that angle D is congruent to itself because of the reflexive property. And we also know that angle DJF is congruent to angle DEH as shown in the diagram. The reason for that is because we have these two lines that are drawn and are parallel. If two parallel lines are cut by a transversal, then corresponding angles are congruent. Now we can state that triangle DJF must be similar to triangle DEG because of the AA similarity postulate. Okay, so now that we know that these two triangles are similar, let's set up a proportion. So here we can say that DF over DH equals to DJ over DE. It seems like that we have certain elements for the proof. For example, we do have DH and we have DE. However, we don't have FH and FE. So how do we get those? Well, what we can do here is express DF in terms of DH and FH by stating that DF is the same as DH minus FH. Similarly, DJ is the same as DE minus JE. So at this point, we can now split the fraction. And we can simply state that dH over dH minus FH over dH, that is equal to dE over dE minus JE over dE. However, we know that dH over dH is equal to 1, and so is dE over dE. So this simply turns into 1 minus FH over dH equals to 1 minus JE over dE. We can simply subtract 1 on both sides of the equation to obtain that negative FH over dH is equal to negative JE over dE. Then we simply multiply negative 1 on both sides to obtain that FH over dH equals to JE over dE. And then we can now flip the fraction by cross-multiplying and dividing on both sides to obtain that dH over FH equals to dE over JE. We're actually almost there, except the fact that we have JE here instead of FE. Well, let's look at the diagram now. Well, according to the given, we know that ray EH bisects angle FEG. So here we can say that angle 1 and 2 are congruent. And obviously, that is the definition of an angle bisector. Moreover, we also know that angle 1 and 4 must be congruent. Why is that? Well, the reason is simply if two parallel lines are cut by a transversal, then alternate interior angles are congruent. Then we can say that angle 2 and angle 4 must be congruent by the substitution or the transitive property. Okay, so what else must be true here? How does angle 3 relate to the rest of the angles? Well, here we know that angle 3 and angle 2, as shown in the diagram here, also must be congruent because we have these two parallel lines that are cut by a transversal and therefore corresponding angles are congruent. So there's one last thing that we can conclude here. Well, here we can conclude that angle 3 and 4 must be congruent because of the substitution of the transitive property from the previous steps. Now, if we look at triangle JEF, what kind of triangle is that? Well, here we have the base angles, basically angle 3 and 4, to be congruent. And therefore, that is an isosceles triangle with JE equals to FE. Because if two angles of a triangle are congruent, then the sides opposite those angles must be congruent as well. So if we go to our previous steps here, we obtain that DH over FH equals to DE over JE. But what do we know about JE and EF? Well, we just figured out that they must be equal in measure. Since JE equals to FE, we can conclude that DH over FH equals to DE over FE. And that's basically how you prove number 5.